Hello, I'm here to give my talk called Putting the Sec in DevSecOps. My name is Chris Hughes. I'm a CISO and co-founder at a company named Acquia, and I also have about 15 years of cybersecurity experience ranging from active duty military and the Air Force. I've been a federal civilian employee with the Navy as well as GSA and the FedRAMP team, and I've also worked at various industry roles across DoD, the federal government, and the commercial sector. I also serve as a board advisor and an adjunct professor, and I'm incredibly active on LinkedIn, where you can find me as Chris Hughes or Resilient Cyber if you go to Twitter. So I was trying to put together an image to show the history of DevSecOps and kind of how we've gotten to where we are today. And I came across this image actually from Shannon Leitz that did a presentation as part of the DevOps Institute. And it was about as good as I could have hoped to come up with one. And it emphasizes the three major movements that we've seen, which are the move from waterfall to agile software delivery, moving from monolith to microservices, and then moving from the data center to the cloud. Also, there's obviously the emphasis around the manufacturing aspect of pulling things from supply chain to what we see today with the software supply chain and where things are headed on that front. So we all know digital transformation typically involves three main pillars, which is people, process, and technology. Obviously, the first piece of that, the people aspect, is the most important for anyone that's been doing this for some time. They'll tell you that. But if you look at the headlines and discussion in the industry, obviously, there's a big emphasis on the technology aspect. That said, I'm definitely going to touch on each of these throughout the presentation and look forward to chatting on some of these with you coming up here. So first up, we have CICD pipelines. And what is the good of CICD pipelines? What have they done when it comes to DevSecOps? So as far as CICD pipelines, which is continuous integration and continuous delivery, we've seen the adoption change, that the way that software is delivered for developers, basically how it's promoted throughout the pipeline and delivered into a production environment. It's also enabled us to pursue what we're calling shifting security left. If you hear a lot, we need to push security left. People keep using that phrase. Using automated security tooling embedded in CI/CD pipelines has helped facilitate that. And it's also allowed us to have robust tool chains that provide full CI/CD capabilities and help us meet our security requirements throughout that process. So it's a great benefit. Everyone that's adopting DevSecOps, obviously CI/CD is a big piece of that, helps them move towards GitOps and declarative state and promoting software from dev test to all the way through production in an automated fashion. But CI/CD pipelines are not all good either. Many organizations basically have a lot of stovepiped, disparate, non-integrated, non-cohesive approach to it when it comes to CI/CD pipelines. They may have a lot of disparate tooling integrated in there, whether it's open source or proprietary tooling. They don't have a kind of a unified, cohesive approach to how they've approached their CI/CD pipeline. They've also failed to account for their CI/CD pipeline as part of the attack surface, basically. And we saw this take place with SolarWinds, for example, where if a malicious actor is able to target pipeline and the way you're producing software, they can have a cascading impact across many organizations. As we saw with SolarWinds, I think it impacted something like 18,000 organizations, I want to say. So organizations that are moving to CI/CD pipelines are focusing on the benefit of that, moving faster, deploying in a way that facilitates the outcomes they're after. But it also is a part of your attack surface and something you need to consider when you think of threat modeling, securing your system, and securing your assets. It's not just what's coming out of the pipeline that needs to be secured. It's also the pipeline itself that must be accounted for. So your CI/CD pipeline enables value delivery, but it also could be a threat vector, as I mentioned. And there's some great resources out there from groups like Cybersecurity. They've released a top 10 CI/CD security list. And if you look at this, it isn't something necessarily that has been unique to CI/CD. Is relevant across many other areas of software development and system development, things of that nature. But definitely some unique ways that malicious actors are looking to take advantage of pipelines. Also, you need to go ahead and, like I said, perform threat modeling and adversary emulation against your pipeline and your tool chain, much like your adversary will do when they look to exploit it and try to compromise what's coming out of the pipeline in a malicious fashion or interrupt your operations, your ability to deliver software. You need to be doing those same things when you look at you're doing adversary emulation and threat modeling your infrastructure and your architecture. Also, of course, we have Salsa by Google, and it focuses on three primary things. It's kind of like a checklist, process that you can look at how you're handling software delivery across the supply chain, and it has different levels of maturity. We're seeing that start to get adopted in the industry, and it really focuses on three core things, which is preventing tampering, improving integrity, and securing the packages and the artifacts that are coming out of your software production process. Another problem we have in the industry is tool sprawl. We've come to a situation where there's so many great open source and proprietary tools to choose from, and so many different functional categories. SaaS, DAS, secret scanning, secrets management, container scanning, producing SBOM, infrastructure as code, manifest scanning, on and on the list you can see. Studies are showing that organizations are using between 10 and 30 different security tools. And most of these security tools are not fully configured. They're not actively being monitored. They haven't really been tailored to your organizational or regulatory requirements. They're not really producing much ROI. And in many cases, the cognitive overload and being placed on your development or security and even your operations team when it comes to some of the tools that they have to choose from is causing a big cognitive overload and actually increasing the risk of the organization. People are spent going in different directions, checking many different dashboards, different tooling output, trying to get all the tools functional, configured as needed, and it's actually causing more risk than it's actually mitigating in some cases. So organizations should definitely take a look at how they are governing their tools, rationalize duplicative tooling and removing duplicative tooling so it's not present and causing challenge on the team, and trying to move towards a more unified approach, where you maybe have a centralized dashboard, you're bringing all this telemetry together that could be seen in a single location and not needing to bounce all over the place. And definitely try to, if you're an IT or a security leader, you don't want to be adding tooling faster than your team can implement it. This is just kind of creating a backlog of tasks for them that they need to get to, and they're not really having time to implement tools, mature them, tune them, watch for behavior of your environment, things of that nature. So tool overload is actually a major problem that needs to be accounted for. So tool governance is needed. You want to take an inventory of your existing tooling, as I mentioned, find duplicative overlapping tooling, and then you want to actually mature tools before moving on to something else. You want to validate that it's actually providing value. Is it driving down organizational risk before getting caught up in the next shiny thing and jumping over to that and chasing the next shiny tool that comes along from a vendor or an open source offering, giving your team time to mature when it comes to implementing that. And also speak to the teams that are implementing this, your development team, your security, your operations folk. They know what the issues are with the tools in the environment, what the challenges are with implementation, some of the tools that aren't really working out so well for them. Speak to them. They know the issues that they've identified, and they can help bring it to your attention as well. So next slide here, we discuss an open source adoption. As you can see, there's a massive landscape. This is taken from CNCF. There's a massive landscape of tools when you think about open source adoption, things to choose from. When you think of cloud and containers, languages, networking, and the list goes on. There's so much to choose from. Much like tools, it can cause a massive problem. It speeds up development. It can speed up development. It produces cohesion and collaboration across the ecosystem of people able to collaborate, come together, work on different tools, produce, different maybe policies that can be leveraged across the community, resolve findings, for example, that a security vulnerability associated with an open source tool that many people are using. And just some metrics to show adoption here. 97% of organizations are using open source. Many have plans to increase their use of open source. And the highest increases around open source is actually these DevOps and cloud native CICD tools that we just talked about in the previous slide there. So people are making massive uses of open source adoption, but there's some challenges with that we're going to touch on here in a moment. So the bad when it comes to open source is that malicious actors are actually noticing that the software supply chain is increasingly fragile. They see that many people are using these open source projects, open source components, but they're not necessarily understanding what they're using. They're not having a good inventory of things that they're using, and they're not really watching for vulnerabilities in the open source components that they're using. So malicious actors know that they can go out there and produce, create these software supply chain attacks in the open source ecosystem, for example, like a Log4j, and have a cascading impact across thousands of organizations, millions of individuals who may be using these open source components, and malicious actors are taking advantage of that. And since organizations lack like a comprehensive, asset inventory when it comes down to libraries and components and things of that nature, they're often sent scrambling, trying to get an understanding of, are we impacted by this? Are we using it internally developed software? Are we consuming maybe a SaaS offering that's using this vulnerable component that has been exploited by a malicious actor? And it's causing a lot of confusion among organizations. And we're seeing a lot of efforts to try to address some of these things in the industry as well. We actually just saw the open source software security mobilization plan that was published by the Linux Foundation and OpenSSF. That was an output of the White House Software Security Summit that they held earlier in January of 2022. That mobilization plan highlights 3 high-level goals and associated work streams. I definitely recommend checking that out. It runs the gamut of everything from education, SBOMs, digital signatures. So it covers many different aspects of the software supply chain. It also covers standing up an open SSF incident response team. They'd be prepared to, for a next Log4j or type similar event, go out and try to help people respond to this, maybe work with the maintainers of the project and resolve the issue, get an update out there, and then work with downstream organizations to resolve it potentially as well if they've been impacted. So what do we do about this? As I mentioned, there's a lot of efforts and promise coming out of groups like OpenSSF and Linux Foundation. NIST has also produced robust guidance around supply chain security. They actually released their new CSCRM, or Cybersecurity Supply Chain Risk Management Guidance, which is NIST 800-161. And if you go take a look at that, section Appendix F, actually, and this was an output of the Cybersecurity Executive Order. If you look at Appendix F, they've still, recommended different maturities of practices, like foundational, sustaining, and enhancing. And if you take a look there, it ranges from software composition analysis, SBOM, taking advantage of VEX to understand not just what components are we using, what are the vulnerabilities, but are they actually exploitable? Working with vendors to get that information from them as well. And then, of course, standing up centralized hardened internal repositories of open source components. Rather than having development teams go out and kind of pool and use whatever they like, you can have an internal repository of known, vetted, and approved software components that they can go choose from. And that brings security into the loop. We talk about baking in versus bolting on. That internal repository is a method to go ahead and facilitate that. You have your security team involved in development with the organization. They're able to, stamp this hardened repository of components that can be leveraged, and developers can go use from them versus just pulling from the open internet without any kind of vetting process or review from security team, for example. Kubernetes, everyone's favorite topic. If you look anywhere in the DevSecOps ecosystem at the moment, everyone's talking about Kubernetes. Everyone's adopting container and cloud native architectures. And of course, Kubernetes is the orchestration tool of choice. And some studies are showing that 75% of global organizations have adopted containers. As I mentioned, Kubernetes, of course, is the tool of choice when it comes to orchestrating containers. And there's many benefits for this. It reduces development timelines. It provides cost optimization. Infrastructure as code. It's kind of an immutable, repeatable process where you can take a container and move it from one hosting environment to another, such as a cloud provider, bare metal, wherever you're deploying to. For example, if you have an air gap requirement in the Department of Defense, is a unique case, for example. So containers have a lot of benefits, and Kubernetes, of course, associated with that, but it's not without its own drawbacks as well. So looking at Kubernetes and containers for security perspective, don't neglect security when it comes to adopting these new technologies. Much like cloud, everyone rushed to adopt cloud, didn't consider security, and now we see a lot of notable cloud security data breaches. When you look at Kubernetes and containers, it's a very similar situation. Everyone's rushing to adopt Kubernetes and containers, but they aren't understanding the nuance, the complexity, and the security concerns that are coming along with that. So there's definitely some alarming studies out there. If you look at studies from Palo Alto's threat research group, Unit 42, they found that 99% of Helm charts and Artifact have insecure configurations. Up to 91% of images in public repositories have critical findings. And these groups are starting to produce guidance. If you look at guidance coming out of groups like the DoD, you look at CIS benchmarks, obviously groups, there's some Bridge Crew, Aqua Security. There's some great groups out there putting a lot of great recommendations out there. I'd be remiss if I didn't recommend CNCF. They have the Cloud Native Security Best Practices Guide, the Software Supply Chain Security Recommendations, and they actually just published the Secure Software Factory reference architecture as well, which I definitely recommend you check out if you're dealing with cloud native architectures, Kubernetes, and containers. So some of the key recommendations I wanted to highlight is, utilizing manifest scanning, container scanning in your pipelines. You definitely want to be scanning, Kubernetes manifests before you go ahead and implement those in a runtime environment, scanning your containers for known vulnerabilities, not just during the pipeline, but in runtime. That's a major oversight by some people. Maybe there wasn't a vulnerability when the container went through the pipeline, but maybe a new vulnerability has been published, for example. So that could be a major problem that you need to address as well. Also using pre-hardened images. Don't just pull images from the open internet. These often, as I mentioned, have insecure configurations or vulnerabilities in them. You definitely want to try and harden your images before you utilize them, reduce your attack surface and strip them down, to only have the required components in the image, and mitigating the attack surface on that front as well. Also, another key recommendation from groups like CNCF and others is to use image signing and hashing. This is so that you understand that the image that you're using from a repository, it has been signed by a trusted source. It is what you believe it to be. Has a source of authenticity, integrity aspect as well. You're using what you intended to use, and you understand what you're putting into your environment. So image signing is definitely a big aspect of that. If you look at security tools, for example, open source tools such as Caverno, they can help enforce, emission control when it comes to Kubernetes clusters, blocking the deployment of images that have not been signed or by the appropriate source or haven't been signed at all, for example, or there's a mismatch of a hash or a signature. So definitely a key consideration. As I mentioned, CIS is of great resource. CNCF, DoD Container Hardening Guide. There's a Kubernetes Security Technical Implementation Guide, STIG out there for those not familiar with that. And then scanning containers throughout their lifecycle. As I mentioned, you don't just want to scan containers, as they go through a pipeline. Of course, you can identify vulnerabilities by doing that, but in the runtime environment as well, it's critical to scan containers because new vulnerabilities come out. Maybe after you've scanned in the pipeline or the container has went through the pipeline, a new vulnerability has been discovered. You definitely want to try to catch those in runtime environments, for example. And definitely update your plans. If you look at cloud adoption, you need to update your incident response and business continuity plans to account for cloud computing. You need to do the same when it comes to Kubernetes containers and cloud native architectures. So updating your incident response plans, your business continuity plans to account for Kubernetes and containers. Who do we get involved? What are the right teams that we need to contact? And ensuring that you're in a position to respond to systems and organizational activities that rely on these technologies is very critical. Also take a look at the vulnerabilities in your infrastructure as code. Palo Alto, as I mentioned, Unit 42 has put some great research out there. They've done the same on infrastructure as code. Much of the infrastructure as code templates that are out there on the open internet for use have insecure configurations or insecure defaults, for example. So you want to be scanning your infrastructure as code manifests before you go ahead and provision, say, something like a CloudFormation template or a Terraform template to provision your infrastructure as code, looking for misconfigurations, vulnerabilities, compliance deviations, things of that nature. Secrets management. This is an absolutely big one that's not being addressed by many organizations. I definitely want to call out a group who has produced some great research on this front, Gate Guardian. If you take a look at some of the research they've done, they actually recently just scanned public GitHub repos and found over 6 million secrets that were sitting in these public GitHub repos exposed. Were all of them maybe active and able to be exploited? Unlikely, but many of them I'm sure could if you go ahead and try to do that. People are very reckless when it comes to secrets management. We're seeing more and more. I think the Samsung data breach, if you look at the source code that was in that, had many secrets committed to it, for example. So secret sprawl and poor secrets management practices is a big one. These typically include, usernames and passwords, API tokens, SSH keys, encryption keys. And the cloud native deployment models and development models have kind of contributed to this. If you look at how people are now baking containers, infrastructure as code templates, Kubernetes manifest, for example, these are all positions where secrets or things that you didn't want to be exposed can be exposed. So definitely take a look at that and integrate some kind of secrets management process. How are you handling secrets as an organization? How are you scanning for secrets before they get exposed, either in a pipeline or if they've even been, kind of committed to a source code repository, for example, identifying those, revoking them, and kind of cleaning up that mess can be a real problem. But you definitely want to try and do that before an adversary finds it and takes advantage of it. So as I mentioned, you want to utilize secret scanning tools in your CICD pipelines, your repositories, looking for your image manifests, things of that nature that have secrets committed to them, and catching them before they get exposed to parties that you didn't intend them to be exposed to. And our issues are not just technical. Actually, in fact, many would argue, folks who have been working in DevSecOps and digital transformation in the past, say 5-6 years, particularly focused on cloud, things of that nature, they'll argue that most of the issues are not technical whatsoever. We have brilliant technologies. We actually lack much of a workforce, people with in-depth knowledge of these technologies and how to use them. So as we look at cloud native architectures, cloud service providers, Kubernetes containers, we're kind of forgetting the workforce. We haven't really upskilled our workforce along with that. So all the talk about DevSecOps and breaking down silos, but if you go into organizations that are operating in this fashion, there's still a lot of siloing going on. Teams aren't talking to one another. There's not really broad communication, understanding what each team is doing, what issues that they are running into that others may be running into, or issues that someone may have already addressed, for example. And much of our DevSecOps conversation is really technology focused, like I talked about, pipelines and cloud providers and containers and things of that nature. We don't really talk about the people aspect enough. Despite that, that 85% of security incidents involve a human factor, we're still overwhelmingly focused on the technology. And we keep saying, security is everyone's job, but are we really equipping the workforce, to take on this task, or are we just, kind of using it as a catchphrase at this point? If you look at security spending, for example, only 3% of security spend is spent on the people, on the human aspect. It's overwhelmingly focused on tools, technologies, vendors, solutions, building things of that nature. It's not really focused on the human. So if security is everyone's job, why are we not investing appropriately to empower people to actually take control of that as part of their job? There's definitely a misappropriation of investment, in my opinion. So as I talked about, the workforce is a big aspect of this. Workforce enablement. So as you're looking to adopt these technologies, you want to adopt DevSecOps, you want to adopt cloud native architecture, for example, but you're not really preparing your workforce accordingly. You have to build a security culture, that it takes deliberate investment and attention. It's not something that's just going to happen organically. You can say the right things and do the right things, but you have to truly take the time to inculcate your workforce with these kind of practices. Let them understand that security is a priority from your leadership all the way down to the lowest levels of individuals, working in the organization. People who may just be starting out, all the way up to the leadership and executive level. This has to be something that's pervasive across the culture, because anyone can actually open the organization to risk. So development, developers, for example, there's a lot that can be done on this front. I talked about earlier the OpenSSF open source security mobilization plan. They really emphasize, I think it's actually the first work stream that's mentioned in there is like development and I'm sorry, developer education when it comes to secure coding practices. Unfortunately, most institutions, traditional educational institutions are not really teaching secure coding practices, but there's a lot of great resources out there. If you look at NIST, SSDF, for example, that's quickly becoming a requirement for vendors selling software to the government. And then OpenSSF actually has a great course out there around secure coding practices. There's, of course, the well-known OWASP Secure Top 10, vulnerability lists for secure coding practices. Take a look at that. And empower developers with tooling. Going back to my comment about silos and things of that nature, for example, developers are often put in a situation where security is kind of out of band. Security has ownership of a lot of the security tooling. They get the telemetry, they get the metrics, they get the dashboards, but then you have to try to go in and inform the developers out of band. Hey, here's the findings we found. Here's the issues that we're seeing, for example. You need to empower developers, and organizations like Sneak and others are actually doing a great job on this front of bringing that bringing that tooling directly to the people in the position to fix the issues and kind of the source of the issue. In many cases, when it comes to insecure code, the developers, they're starting to empower those folks with tools directly versus kind of keeping security out of band and having a third party perform those activities. Another one is just upskilling the workforce around these technologies. We're talking about adopting cloud, moving towards DevSecOps, moving towards Kubernetes and containers. There's so many great resources out there when it comes to upskilling the workforce. A couple that I wanted to highlight is Cloud Security Alliance's CCAK, which is Certificate of Cloud Auditing Knowledge. It's actually the first, kind of cloud vendor agnostic, auditing or compliance certification out there. And it dives deep from a compliance perspective and lets folks know, like, what should I be looking for? What's different in the cloud paradigm when it comes to GRC, governance, risk, and compliance. So that's a great resource. And of course, Linux Foundation. They have certifications around things such as, DevSecOps, Kubernetes, and containers. They have great courses, such as Certified Kubernetes Administrator. They also have the Cloud Native Associate Exam, which is, not so deep in the weeds on command line, for example, like the CKA exam. It's more broad understanding of the cloud native ecosystem. And then others, of course, is A Cloud Guru, Pluralsight, and Udemy. So those have great resources too. If you go take a look at any of these sites, they're going to have courses on DevSecOps, on containers, Kubernetes, your cloud service providers that you're using, your AWS, your Azure, etc. So don't forget the workforce aspect when we talk about trying to improve things. And the last piece I really wanted to highlight here is the culture aspect of things. If you look at the latest report, State of DevOps report, for example, it shows that organizations that have a generative culture that's focused on, growth and psychological safety and things of that nature, they actually have better performance, better software delivery. They're more mature. They're achieving better business outcomes, which is really what we're after with all of these, these pursuits of DevOps or cloud, et cetera. It's all really to empower the business and delivering value to the stakeholders in a more efficient, more effective manner. And another thing that, we're really calling out here is that, changing the paradigm of promoting good ideas over ranks or titles, having that kind of meritocracy where any good idea that anyone has, regardless of who they are in the organization, will be heard, and recognized and adopted if it makes sense for the organization. And this goes back to what I talk about, talking to the people doing the work, understanding the challenges they're running into, and being receptive to that sort of a feedback that they're providing, for example. These and also having that kind of a culture. These studies are showing that it reduces burnout. Having a psychologically safe environment where people can come, they can express challenges they're running into, things they need help with, and not feel intimidated by rank or title. In somewhere where people can feel safe to like maybe get something wrong, maybe they don't know everything, and that's okay. That's very healthy. You need to promote that people can communicate with one another. No one knows everything, and it produces a culture where people feel much more safer of sharing their ideas, their thoughts, their challenges, their struggles, and it connects the workforce much better. I'm a big proponent of remote work, but it's not all rainbows and sunshine as well. People are often disconnected, and we're seeing a lot of burnout. The line that has previously existed between work and home life has kind of fell down as we've seen, remote work take more and more prevalence in the workforce. Everyone knows the feeling of, just being at home. You're not near a desk per se, but maybe your phone is buzzing. You're still getting emails. You're still getting Slack messages. So that kind of workforce, that kind of paradigm of being able to disconnect and leave the work site, for example, is gone as we've kind of adopted remote work. So you have to be intentional about building a culture where people feel it's okay to disconnect. It's okay to be unavailable for certain times of the day if you're off doing things personally, for example. So we say our people are our greatest asset, and I think it's time that we need to really act like it, invest in them, build the type of culture that is going to lead to that success and better business outcomes that we're after as an organization, as an industry as well.